Hi, this is Kevin C. from Santa Rosa Junior College. We're here today at Carlsen and Associates to look at line pumps.
I'm John Johnson, Sales Manager of Carlsen and Associates, and glad to take the time to show you folks how to run some of these things and some of the specific functions of the different pumps. The first one here is called an air-operated diaphragm pump, and it is very gentle on the juice. It doesn't handle solids well, but it's very good for barrel work and things like that. Typically on an air diaphragm pump, your inlet's on the bottom, your discharge is on the top, and this column here is set up to absorb the surge that is inherent with an air diaphragm pump. When the shuttles shift back and forth, it tends to create a surge in the line, and you'll see the hoses jump and things like that. With a little bit of back pressure, the air absorbs that surge and gives you a lot more steady flow. As far as hookups, this particular pump is a tri-clamp. There are a number of different ones out there, from tri-clamp to I-line to Pacific Coast thread, but this is by far the most common, would be the tri-clamp. And you have a small gasket that goes in between. The clamp comes up, locks in place, and you tighten it down. You now have a solid surface between, or a solid seal between, in this case, the inlet of the pump and the incoming hose, incoming valve, whatever you happen to be using. And very, very easy to disconnect. Again, just loosen it up, pop it off, and you're good, and very, very easy to sanitize. Normally on an air diaphragm pump, you also have the air valve, okay, and the air filter regulator. The air filter pulls out any moisture that maybe be in the incoming air line, and you can regulate the pressure so you don't blow hoses and things like that. You can shut off against an air pump, and it will simply stall the pump, and it will only go to the pressure that you have set. Under normal circumstances, you would set that pressure by raising up on the knob. The air diaphragm pump is considered a positive displacement, but the most common type of positive displacement is a rotary lobe pump. In this case, the Waukesha is what we sell. The Waukesha is a winged rotor, so it doesn't have any pinch points to crush seeds and things like that. You would normally have the variable speed control, which is a 50-foot handheld remote control from 0 to 100%. You would have, in this particular case, it doesn't care which is suction and which is discharge. It has the forward and reverse switch on the panel itself. So if I'm this way, my suction would be here, which is also indicated by forward flow sticker on top. You go reverse, and now my suction is here, and this becomes the discharge. The pump is just as efficient in both directions, so it really doesn't care which way it goes. Unlike the air diaphragm pump, if you have this thing set up to do X amount of speed, say 60%, it will do 60% even against a closed valve if it has to break a hose to do it. So the positive displacement pump will easily produce pressures in excess of 100-150 psi. So it is very, very important to remember that that will deliver X number of ounces no matter what. And you've got a lot of versatility in the positive displacement for barrel work, for filtration, for handling must. Very easy to clean, very easy to maintain, and average life of these pumps is about 20 years. In this particular case, this is a Waukesha 130. It'll do 0 to 135 gallons per minute, and it'll do upwards of 80 or 85 psi without having any problem at all. Inside the control box are the controls themselves. In this case, it's a Yaskawa P1000 drive. The box is watertight. Rubber button covers on everything. It also has the capability of remote control, which is this pigtail down here, if I wish to hook a float to it, or a bottling line, or a remote stop-start, so I can walk around and stop and start the pump as needed. Very simple operation, very easy to maintain, take apart, and clean. Okay, this style of pump is considered to be a centrifugal pump. It is typically a higher speed. Maximum speed on the Waukesha 130 was 547 RPM. Maximum speed on these is upwards of 2100 RPM. It is primarily used for high volume juice transfer. Does not produce a lot of pressure. About 37 psi is normal for the standard transfer pumps. You have a stainless steel impeller inside that always rotates this direction, and your discharge here. In this particular case, you'll also see how the discharge is pointed slightly up. That's because these pumps are not self-priming. They will create a suction after they've been primed, but upon initial operation, they are not self-priming. We point this discharge up a little bit to help evacuate the air that's in the head, and it helps the pump prime much easier. Again, variable speed, 50-foot handheld, okay, stop, start. There is no reverse on a centrifugal. It is one direction only. And just so you don't get mixed up, this front piece is always the inlet, and this is always the discharge. Some of these pumps will go upwards of 600 gallons per minute. The smaller ones are down in the 80 or 90 gallon a minute range. Again, pressure ranges from 20 psi to about 37 psi. We do make one particular pump specifically for tank washing that'll do 80 GPM at 80 psi, but that's almost a dedicated application for tank washing. Any of the Cloud, the Gamma Jets, all the normal tank cleaners take typically 80 GPM at 80 psi. Also very easy to clean. This clamp comes off, this whole face comes off, and you've got the impeller and the mechanical seal. One of the things you do have to be careful on a centrifugal is not to run them dry. The air pump doesn't care about running dry, the Waukesha doesn't care about running dry, but the centrifugal, if you run it dry, what it does, it will heat up the mechanical seal, and that can be about a $300 or $400 error. Price-wise, a 140 gallon a minute pump in a centrifugal is about half that of 140 gallon a minute positive displacement, and about 20% more than a 140 gallon a minute air diaphragm pump. The only change on the air diaphragm pump is you do have to have an air compressor, where these are all self-contained. They'll run on typically 3-phase. They can be rigged for single phase, 220 if necessary. Again, all of them portable on carts, so it's nice to be able to move that around. One other piece of the puzzle I don't have an example of here today. One of the things that's becoming very, very popular is a centrifugal pump, typically smaller than this, in the 3-horse to 5-horse range, that is mounted to the base of the tank leg and have a dedicated pump per tank. And that way you don't have the manpower to hook things up, you don't have the manpower to clean, disconnect, and you don't lose any juice. It just stays in place all the time and does its pump overs many, many times based on a PLC or a tank net device, a tank controller that says, okay, every 6 hours I want to turn the pump on for 20 minutes. The popularity of that type of system is gaining ground very, very quickly. Again, using centrifugals, but a dedicated one per tank.
All right.
As I mentioned earlier, the centrifugal will only do about 37 psi, which means you can't shut off against it typically without exploding hoses. However, bear in mind when you do that, you now have a blender going on inside this pump head, because that pump head is going anywhere from 1750 to 2100 RPM, and you will tend to create DO and a number of other things, warm up the wine, all kinds of things if you shut off against a centrifugal, especially for any long period of time.
All right, go for it.
One of the things that you do have to be mindful of in using any of the pumps is cavitation. In most cases, you will see the inlet is bigger than the discharge. That's because the pump is easier to push something out than to inhale the liquid. In the case of the Waukesha 130, you've got 3-inch in, 3-inch out, in this case reduced down to 2 and 2. You do have to be careful on the Waukesha not to run a high speed with a small inlet. In most cases, I'll recommend people run a 3-inch inlet and a 2-inch discharge. Cavitation is very, very hard on the wine, and it's also hard on the pump itself. If you were to watch the amp draw on a centrifugal, your amp draw spikes drastically more in a cavitation situation where I can't feed it as fast as I'm discharging. With the air pump, what you see in a cavitation situation is DO, and also the hoses will bounce and jump a lot more than what you would see if it's being fed at an adequate rate compared to the discharge. Okay. Cavitation is effectively creating an air pocket on the back side of the rotating object. You would see that most commonly like in a submarine or something like that. In a submarine, they try to minimize cavitation because that minimizes the amount of sound that can be picked up on sonar and things like that. You will hear the pump cavitate. If it cavitates, it makes kind of an unusual growl, and you're effectively creating an air pocket on the back side of the blade because it's putting too much suction without enough liquid.
To avoid that, you just make sure the upstream flow is adequate.
Make sure your inlet has adequate flow. What you would find cavitation most common when your inlet is somehow restricted. Normally there's 3 types of hose inside a winery. There's what is typically referred to as Canaflex or Canaline, which has the ribs on the outside. Okay, it's normally clear, you can see the liquid. It will handle X amount of temperature, it will handle X amount of pressure. You do have to be careful not to exceed those numbers. The next step up from that is what's called Kuriyama, or a number of different manufacturers make it, where instead of having the PVC helix on the outside, it actually has a stainless helix in the mold itself on the inside of the hose. And I don't really have one apart that you could see better, but it's the upside. It will handle a little more pressure, it will handle a little more temperature. It is substantially heavier than the Canaline. Then you go up one more step and you have what a lot of people call wine hose, which is not clear. It is wire reinforced inside the mold itself. In our particular case, we crimp on all the collars instead of banding. This hose will handle drastically higher pressures. If you were transporting a long distance with a positive displacement, for instance, you'd probably want to go to this type of hose, where this would handle any of the centrifugal applications along with the Kuriyama. In many cases, we've got people using 6-inch positive displacement pumps, pumping hundreds and hundreds and hundreds of feet, and a Canaline hose would break apart immediately. So that's why they have to go to the heavier wine hose or fixed in place stainless steel lines.
All right.
Now let me get it loose first. Okay, as I mentioned, the Waukesha is a 3-inch inlet, 3-inch discharge. In many cases, especially if you're feeding like a bottling line or something like that, you wouldn't want to use 3-inch hose to do so. So you can adapt it down 3 to 2, 3 to 1.5, 4 to 3, all the different combinations. Again, in this case, a Buna gasket. Hold it up, put on the clamp rings, and tighten it down. Very easy to take apart, very easy to